so for the likes of these easy ones, I'm just going to do them out and you can look through my solutions. I took down A, B and C, and what I decided to do was get rid of my x's. So I just wrote B and C beside each other because my x's would cancel, and I came up with the equation D. On the right hand side here I took A and I multiplied B by 2. Because if you multiply B by 2, you'll have a 2x and a minus 2x. So my x's cancel and I come up with equation E. What I've done here is I've grouped equation D and equation E, except I've multiplied equation E by 2, so that I have a 4z on the top and a minus 4z on the bottom, and I'm just left with y's. I end up with 15y equals minus 15, so I work out the value of y is equal to minus 1. Once I've got that, my little arrow here goes up to this. I subbed in my value for y into the equation E, and I ended up with z is equal to minus 3. And once you use your value for y and your value for z, if you sub these two answers into one of these original equations, you'll get x is equal to 2. Okay, so the next question I'm going to look at here is where they ask you to investigate if 3x minus 1 is a factor of this cubic. Now, if 3x minus 1 is a factor of the cubic, that means if I divide it in, my remainder will be 0. I just want you to be aware you're allowed to turn this factor into a root and actually investigate if it's a corresponding root. So I'm going to show you that method at the end, but for the moment let's deal with it as a factor. If I divide this into this, if it's a factor, I should end up with a remainder of 0. Now when you're doing your long division, you've got your 4 different steps that you have to follow. The first step is you divide. So you divide the first thing here into the first thing here. 3x into 6x cubed goes 2x squared times. My second step is to multiply. So I get what's on top here and I multiply it by both of these. 2x squared by 3x is 6x cubed. 2x squared by minus 1 is minus 2x squared. My third step is to subtract. And in order to subtract, you have to change your signs. So that becomes a minus, that becomes a plus. My x cubes will cancel. And minus 5x squared plus 2x squared will give me minus 3x squared. My fourth step then is you take down the next term, which in this case is a plus 4x. Once you've finished your fourth step, you start the process all over again at the top. 3x into minus 3x squared goes minus x times. That's my divide. Multiply minus x by both of these. I get minus 3x squared plus x. And change my signs in order to subtract. My x squareds cancel. 4x minus 1x is 3x, and you take down the next term, which is plus 5. We start the process all over again. 3x divided into 3x goes once. 1 by 3x is just 3x. 1 by minus 1 is minus 1. I change my signs, and I get a minus, and I get a plus. My x's cancel, and I'm left with 6. So my remainder is not 0. My remainder is not 0. That means my conclusion is that 3x minus 1 is not a factor. Okay? That means 3x minus 1 is not a factor. I don't need to do anything else. If it asked me to solve it, I'd factorize these and get my other two factors, or my other two roots. Now, I want to show you the other way of doing this. You are actually allowed to convert 3x minus 1 into a root and investigate if it's a root. So if you just want to pause that, I'm going to start this again on the top of the board. The alternative way of doing this question is you could do it like this. You could take the factor 3x minus 1 equals 0 and isolate your x. If you bring the 1 across, it becomes a plus, and divide both sides by 3, you get x equals 1/3. So if 3x minus 1 is the factor, the corresponding root is x equals 1/3. So you can investigate if x equals 1/3 is a root of this cubic. And in order to do that, you just sub it in. But when you sub it in, make sure you let it equal to 0, because you have to indicate why you're subbing it in. If this works out as a root, the whole thing should end up as 0. Now when you plug this into your calculator, it actually works out as 6. Clearly 6 is not equal to 0, so you can say that x equals 1/3 is not a root, and therefore that means that 3x minus 1, the corresponding factor, is not a factor. In the next part of the question, we're told that this quadratic is a factor of this cubic, and therefore prove that q is equal to minus times a or plus 1. Now, at the start of a question like this, what you're trying to get to seems like gibberish. So for the moment, I think you just have to ignore what your answer needs to be. What you need to hone in on is that this is a factor of that. If this quadratic is a factor of this cubic, that means if I divide it in, the remainder will be equal to 0. So I'm going to use long division here, and I'm going to work out what my remainder will work out as. So it's the same 4 steps as we used in the previous part of the question. The first step is divide. You're going to divide x squared into x cubed, and you're going to get x. Your second step is multiply. X multiplied by x squared is x cubed. X multiplied by ax is plus ax squared. And x multiplied by minus 1 is minus 1x. My third step here is to subtract. So I change all my signs. Minus, that should be a minus, and a plus. My x cubes will cancel. And this is where I think you need to be careful. On the top line there, I have px squared, and on the bottom line, I have minus ax squared. So usually, if these were numbers, this would be just 8 minus 4, or I would just do it in my head with numbers. Here, the easiest way to write this is to factorize out the common term. Common to both of these terms is x squared. So if you take out x squared, you're left with p minus a, which means the easiest way to write this is p minus a times x squared. I do the exact same thing with the x's. On the top, I have a qx, and on the bottom, I have plus 1x. Now, it's important you remember that's a 1. A lot of people would just have written that as x, and they would forget about the 1 here. I factorize out what's common. X into the first term is q, x into the second term is 1, and that's going to be the easiest way for me to write this. Q plus 1 times x. The fourth step in my long division is to take down the next term, which in this case is plus 4. And now I'm going to start my process all over again. X squared into this is going to give me p minus a. And then my second step is to multiply. So p minus a by these 3 terms. P minus a by x squared is p minus a times x squared. P minus a by ax, I'm just going to write that as p minus a times ax. I wouldn't bother simplifying it down because I know that I'm nearly at my remainder. I know I'm nearly at my remainder because there's no more terms here. There's no extra terms to take down, so I'm on my it's the last time I'm going to have to do the 4 steps. Now I need to multiply p minus a by minus 1, and that gives me minus times p minus a. Now I'm going to change my signs and subtract. So I get a minus there, I get a minus there, and I get a plus here. The x squareds will cancel, and you need to divide your line now into 2 different remainders. Again, we know we're at our remainder because there's no more terms to take down. On the top, my coefficient of x is q plus 1. And on the bottom, my coefficient of x is minus p minus a times a. I know, because this quadratic is a factor of this cubic, I know that that remainder is equal to 0. My other remainder are the numbers that have no x's in front of them. On the top, that's an or, and on the bottom, that's plus p minus a, and I know that that is equal to 0 for the same reason. So I have 2 separate remainders, 2 different equations, and I know they're both equal to 0. It's only at this point that I would start to worry about what I'm trying to prove. I need to prove that q is equal to minus times aor plus 1. Now, the problem you have here is there's no or in this equation and there's no q in this equation. There's a p in this equation and there's a p in that one. I don't want a p in my answer. So the only way to solve this is by substitution. The easiest way to do that is to isolate your or on this side. If you get or on its own, you're left with minus times p minus a. Now, you should recognize that minus times p minus a is actually in the other equation. That means that instead of minus times p minus a, I can substitute in plus or. So that actually makes my life really easy here. Because if I now, instead of minus times p minus a, if I sub in an or, my left-hand side just becomes q plus 1 plus or times a, which is equal to 0. And all of a sudden now, I've got all the right letters, I just need to manipulate it around. Clearly what I want to do is isolate my q. So if I get q on its own, if I bring the 1 to the other side, it becomes a minus 1. And if that's a multiplied by or is just a or. If I bring that to the other side, it becomes minus a or. Now you want to write it exactly the same as they have it in the question. So you realize all they're doing is they're factorizing out a minus 1. If I factorize out minus 1 into minus 1 will go 1 times. So that will just become a plus 1. Minus into this will go plus a or times. Just to make sure you haven't cheated with your signs, multiply it out again just in your head. Minus 1 by 1 gives me minus 1. Minus 1 by plus a or gives me minus a or. So I know that I haven't cheated. Now just to be sure, I'd write it exactly the way they had it in the question. So I just rearranged, I just write them in the other order. Q is equal to minus times A or plus 1. Okay, so now for the next part of the question, this was where you were given your log problem. Now, in the Leave Insert, the vast majority of log problems are identical to this. The only difference is they use different letters. Instead of an or a K or an N, they might use Q and A and B. They just literally use different letters, but it's the exact same every time. At the very start, it told you that you started off with 100. So if they told you at the very start n is equal to 100, you need to realize what they're actually telling you is when t is equal to 0, n is equal to 100. It says 5 hours later, or in other words, when t is equal to 5, then n is equal to 600. So they're the two pieces of information that they've given you. We can use those two pieces of information, first of all, to find the value of or, secondly, to find the value of k. Now in these questions, you're always looking out for when t is equal to 0. Because I want you to notice here, technically, if they tell you t and n, then you've got two unknowns. Your unknowns are or and k. If you've only got one equation and two unknowns, it's usually impossible to find the value of either one, unless you can sub in a 0. Because if you can sub in 0, then the k will cancel out. All of a sudden, your only unknown will be or. So in these log problems, always look out for when t is equal to 0. If I sub this in, I'm just going to get on the left-hand side, it's 100 is equal to or times e to the power of k times 0. Obviously, k times 0 is just 0, so I could view this as 100 is equal to or times e to the power of 0. And one of the rules of powers in your log tables is that any number to the power of 0 is equal to 1. So you can just finish this off by saying that or is equal to 100. And in other words, by doing that for the rest of the question, I know that or is a constant, so that's always going to be a 100. The only variables here are n and t. So once you find the value of or, it's always the same. Now we're going to find the value of k, and it will always be the same. To find the value of k, the next thing I need to do now is use the other piece of information. When t is equal to 5, n is equal to 600. So the left-hand side becomes 600, and the right-hand side is 100 e to the power of 5k. All of a sudden now, I've got one equation, one unknown, which means I can find the value of k. You should recognize if your unknown is in the powers, you're going to have to introduce logs here. Before you introduce logs, you have to isolate the term that has the unknown in the power. And in order to do that, I need to divide both sides by 100. If you divide both sides by 100, you'll get 6 is equal to e to the power of 5k. Now there's a number of different ways of introducing your logs here, so I hope I'm doing it the same way as you have been doing it. In this case then, my unknown is in the power, so what I need to do is introduce logs. And what I'm going to do is introduce the natural log ln. And if you do that, it literally just means you put ln in front of the left-hand side and ln in front of the right-hand side. Now the reason we're introducing logs here is because now we can apply our rules of logs. The third rule of logs says that if you log of something to a power, then the power can just come in front. So you can write this as 5k ln e is equal to ln 6. Now ln e is just equal to 1, so we don't need to worry about that at all. So I need to get k on its own. In order to get k on its own, I'm going to divide both sides by 5, which means I end up with k is equal to ln 6 divided by 5. And it asked me to leave this to 4 decimal places. So if I get this to 4 decimal places, my final answer is 0.3584. Okay, so the moral of the story there is I want you to just always look out for t equals 0. If you can get t equals 0, it allows you to find the number in front of the e, and then you'll be able to work out the power. Now, the first part of the question is usually to find the number in front of the e and the number in front of your t. Now you need to realize that this is a very straightforward formula. There's just two unknowns. If they tell you n, you can find t. If they tell you t, you can find n. The next part of the question, they tell you that n is equal to 12,000. What is the value of t? So it literally just means you sub in. You sub in on the first line, then you've got one equation, one unknown, so you can find the value of t. Your unknown is in the power, so the only way to solve this is by introducing logs. But before you introduce logs, you have to isolate the term that has the unknown in the power. In other words, isolate the e. In order to do that, I divided both sides by 100, and I got 120 is equal to e to the power of this. Now that I've isolated this, I can introduce logs. I introduced the natural log on the left and on the right. The reason I introduced logs was so that I could bring the power in front. All of a sudden now I've got no more powers. ln e is just equal to 1, and I want to get t on its own, so I need to divide both sides by the coefficient of t, which means I get t is equal to ln 120 over what was the coefficient of t. And if you plug that into your calculator, t is equal to 13.357957 hours. The next question I want to go through here is your quadratic equation with the powers. So I'm given this, and I'm asked to find the value of x. So you need to recognize straight away that this is actually just a quadratic equation. And the easiest way to solve this is by substitution. Everywhere there's a 3 to the power of x, you should sub in a y. And once you've identified that that's what you're going to do, the second term and the last term are very straightforward. Minus 10y minus 8. My problem lies with the first term. The first term is 3 to the power of 2x plus 1. Now you should view that, you can rewrite that actually as 3 to the power of x plus 1. Okay? Now the first rule of powers in your log tables is that a to the power of p plus q is equal to a to the power of p multiplied by a to the power of q. What I have over here is the left-hand side of this rule, and I want to just move over to the right-hand side. Based on this rule, 3 to the power of x plus 1 is the same as 3 to the power of x times 3 to the power of x times 3 to the power of 1. Now I can go back up and look at my substitution. That just means that this is just y multiplied by 3. 3 by y works out as 3y squared. So my first term here just simplifies down to 3y squared. Now if you were to factorize this, your factors would work out as 3y and y, 4 and 2 minus and plus. Okay, so you get 3y plus 2 times y minus 4 equals 0. So obviously if I need to find the value of x, I need to solve this. So I could say that 3y plus 2 equals 0, which means that 3y is equal to minus 2, which means that y is minus 2/3. My second one, I could say that y minus 4 equals 0, which means that y is equal to 4. So that gives me my two values for y. But obviously the question didn't ask me to find y. I just invented y at the start of the question. The question asked me to find the value of x. So I need to go back on my substitution here. If y is equal to minus 2/3, then that means that 3 to the power of x is equal to minus 2/3. If y is equal to 4, then that means that 3 to the power of x is equal to 4. 3 to the power of x can never be negative, so I can eliminate that answer. And I now need to worry about 3 to the power of x equals 4. Clearly the answer to this question is not a whole number. 4 is not a multiple of 3. X is obviously a decimal. So the only way I'm going to solve this is by introducing logs. If my unknown is in the power, I'm going to introduce logs. So I'm going to introduce the natural log, which is ln 3 to the power of x equals ln 4. The reason I introduced logs was because now I can use the rules of logs. Log of something to a power, the power just comes in front. So I can write that as x ln 3 is equal to ln 4. In order to get x on its own, I'm going to divide both sides by ln 3. So x works out as ln 4 divided by ln 3. ln 4 over ln 3 works out as 1.26. Okay, I want to move on now and talk to you about the financial maths. In this question, we're told that John wants to borrow X euro at an interest rate of or% and that the repayment amount is a euro. Okay, and we're asked to prove that the amount of money, P1 represents the amount of money that John is going to owe in a year. If he pays a euro, how much money will he then owe? And we're asked to prove that P1 is equal to X times 1 minus or, and that should be a minus a. There was actually a typo in the question there, so they should have put in a minus a. So in order to work out how much John owes in a year, the most logical way of thinking about it, it's literally just how much money he owes the bank minus how much he pays them back. If I owe a bank 10,000 euro and I pay them 1,000 euro, that means I now owe them 9,000. So it's as simple as that, and that's what we're going to work out. So the repayment I know is A, and what I need to work out is how much money John owes the bank. So obviously we need to take into account the interest rate here. The way this would be calculated is you would work out what is the present value of a future payment by using this formula. Okay? So in this case, I know my interest rate, instead of an I, I'm going to use or. I can leave t as it is. This is the formula that's in your log tables. And I know that the amount of money that John borrowed, John borrows X euro. And let's say the interest rate or is 3%. That means that the amount of money he owes will be multiplied by 1.03. Or in other words, I'd add on 3% to it every year. So the first year I'd add on 3%, the second year I'd add on 3% of that, the third year I'd add on 3% of that. So basically this just, imagine this is a 10. This just, basically that means I would add on 3% at the end of every year for 10 years. Okay? But that's the formula that the bank would work out to represent how much money that John owes them. Now we're concerned with, we want to know how much money will John owe them in 1 year. In 1 year, then t will be equal to 1. In other words, the interest rate will have been applied once. So John originally borrowed X euro. And the interest rate, which is 1 plus or, that will be applied once. In 1 year, that interest rate will have been applied once. So that will represent the amount of money that John owes the bank in a year. And then I just need to subtract how much he pays them back. If he owes them 10,000 and he pays them back 5,000, then he only owes them 5,000 now. If he owes them this much money and he pays them a euro, I just subtract this, and that tells me how much money John owes the bank in 1 year, which is represented as P1. So that's what they were looking for in that question. Okay, for C part 1 of this question, we're asked to convert an annual interest rate of 4% into a monthly interest rate. Whenever you're starting these questions off, I'd always just start off with this logic. Clearly, the annual interest rate to the power of 1 is equal to the monthly interest rate to the power of 12. So we always represent interest rates as 1 plus I. So I could say the annual interest rate to the power of 1 is equal to the monthly interest rate to the power of 12. Where this is going to represent the annual one, this is going to represent the monthly one. Clearly, I'm looking for the monthly interest rate. They've told me that I, for the annual interest rate, I is equal to 4%. But I don't want it as a percentage, I need it as a decimal. To convert from percentage to decimal, you divide by 100. Which means actually, in fact, I is going to be 0.04. So I know that the monthly interest rate will be 1 plus 0.04, or in other words, 1.04 to the power of 1. And I'm looking for I. And at this stage, you can just view it as algebra. You're just trying to isolate your I. In order to get rid of the to the power of the 12 here, you can write this as 1.04 to the power of 1/12. If I get the right-hand side to the power of 1/12 as well, I just end up with 1 plus I to the power of 1. Clearly, I don't actually need the brackets there because it's to the power of 1. So if I want to get I on its own is just going to be all of this, 1.04 to the power of 1/12 minus 1. Which means that I, in this case, the interest rate is going to be 0.00327. Or in other words, 0.327% per month. Okay, so for C part 2 in this question, now I've got a lot of it done already, so I want to just talk you through it. I know that John's interest rate, monthly interest rate, is going to be 0.00327. And he's going to pay this loan back over 20 years, which means that's 240 months. And I know that overall he has to pay back 150,000 euro. Now, based on that, what I have on the top here, I can come up with a geometric series to describe what's happening. I know that the 150,000 euro is going to have to be equal to all of the repayments he makes. Now, clearly there's 240 repayments in this row, so I'm not going to write them all out. But it's important to write the first few and then the last one. If you take out a loan, obviously you're not going to pay back, you're not going to make the first repayment straight away. So what John is going to do is his first repayment is going to be 1 month after the loan has been made, which means that the interest rate will have been charged once in that time. So to represent his first repayment, it's the value of his repayment divided by 1.00327 to the power of 1, because this is 1 month after the loan has been taken out. The next repayment is going to be made a month later, so this time the interest rate will have been applied twice at that stage. So this represents the value of the second repayment. And then obviously there's a load of repayments in the middle, and then I just do dot dot dot. If the first repayment was to the power of 1, then the last repayment will be to the power of 240, because I know that there's 240 repayments in total. Okay, so once I've come up with that, this is actually a geometric series, and now I can come up with my A, or my first term, my common ratio, and my Sn. I've already mentioned that Sn is 150,000, that n is 240. The first term A will be this term. The first repayment that he made was P over 1.00327, but I'm factorizing out my P because it'll be easier for manipulation. So I'm writing my first term as P times 1 over 1.00327. My common ratio is any term divided by the previous term. So if you took this term and divided it by that term, you'd just be left at 1 over 1.00327. So that's my A, or N, and Sn. Now so if I now sub into the formula for the sum of a geometric series, the only unknown I'm going to have is P. So you'll notice here that I've already subbed it in. I've subbed in my Sn, I've subbed in my A, I've subbed in my OR. So from here on out, you can just manipulate this around. So maybe I want you to work on your manipulation there, because the calculator work here can be tricky enough. I'm going to simplify this down on the next slide. Okay, so all I've done on this page is I've kind of isolated my P. My advice here is try and use your calculator as little as possible, because a lot of these questions you need to keep going to 5 or 6 decimal places in order to get the answer accurate. The first thing, so this is where we left off the last stage, and all I would do next is multiply both sides by the denominator. If you multiply both sides by the denominator, basically this bracket just goes up here, so it's 150,000 multiplied by that. The next thing, in order to get P on its own, I would divide both sides by the coefficient of P, or in other words, all of that. So it's what I had on top divided by all of this. You plug it all into your calculator in one go, you get 902.97, or in other words, 903 euro. So John's annual repayment amount is 903 euro. The next question I'm looking at here is the one on patterns, where you were given four different objects, and you just need to come up with the pattern yourself. So the pattern here works out as 1, 7, 19, 37. And it asks you to describe what kind of a pattern you have. And in order to do that, you should realize the 3 main patterns on the Leaving Cert course are linear, quadratic, or cubic. Linear has a common first difference, quadratic has a common second difference, cubic has a common third difference. When I worked these out, my first differences was plus 6, plus 12, plus 18. My second difference was plus 6 and plus 6. So to describe the pattern, you can say the second difference is common, therefore it's a quadratic pattern. Now the next part of the question asked you to predict what the fifth pattern would be. In order to do that, I would continue on my second differences. I know my second differences will always be plus 6. If the first difference here was plus 18, and I'm going to add 6 to it, that means that the next first difference will be plus 24. So if my fourth value is 37, and I'm going to add 24 to it, that means that my fifth value will be 61. So the answer to that, the fifth pattern, would be 61. In part D of this question, they asked you to come up with the general formula to describe the quadratic. Okay, so you know, you've been dealing with quadratics since first year. You know that every quadratic can be written in the form of an squared plus bn plus c. So that's our starting point. And based on what we've done in the previous part of the question, you can work out what your a is. In every quadratic equation, the second difference is equal to 2 times a, where a is the coefficient of your n squared. So straight away you can say that 2a is equal to 6, because that was our second difference from the first part of the question. If 2a equals 6, then clearly a is equal to 3. Based on that logic, I now actually know that my quadratic equation can be written as 3n squared plus bn plus c. And the point of this question is to find the value of b and find the value of c. Clearly, if you have 2 unknowns, you need to come up with 2 equations. I can come up with my first equation by using the fact that t1 is equal to 1. I know the first term here is equal to 1. That means that if I sub in n is equal to 1, then the value of that term would be 1. And that's exactly what I've done here. The value of my term is 1, and the value of n is 1 in each case. When I simplify it down, I get b plus c is equal to minus 2. That's my first equation, but it's impossible to solve if you have two unknowns in one equation. So now I need to move on and get another equation. And to do that, I use the fact that the second term was equal to 7. that means that if I sub in n equals 2, the whole thing will be equal to 7. And again, notice I'm subbing into this general formula. So I get 3 times 2 squared plus b times 2 plus c is equal to 7. If I simplify that down, I get 2b plus c is equal to minus 5. All of a sudden now I've got two very easy equations, two unknowns, so I can do a simultaneous equation. If you do a simultaneous equation here and you solve it, your values work out as b is equal to minus 3 and c is equal to 1. Which means that once you know that, you make sure you go back and the last thing you write down is the quadratic equation. Now I'm running out of space, so I'm going to do it at the top here. I originally said my quadratic was an squared plus bn plus c, but I know the value of a, b, and c now, so I can actually say that it's 3n squared, and instead of bn, it's minus 3 times n, and instead of c, it's 1. So the general formula to describe that quadratic equation is 3n squared minus 3n plus 1. The final part of this patterns question asks you to work out the value of n for which there are 397 blocks. In other words, which term has 397 blocks? And you know that the general formula to describe your quadratic is this. I want to know when will this quadratic be equal to 397, and now I can find the value of n. Clearly you've got an n, that should be an n squared. Clearly you've got an n squared, an n, and a number, which means you have a quadratic equation, so you should bring everything to one side. So you should subtract 397 from both sides, and you get 3n squared minus 3n minus 396 equals 0. Now you could factorize here, but you'd be making life very hard for yourself, so you're better off to divide both sides by 3. In which case you'll get n squared minus n minus 132 equals 0. And when you factorize this, the factors of 132 that have a difference of 1 are 12 and 11. So you get n minus 12 and n plus 11. Now clearly I need to solve this, I need to continue on. If I solve that, I get n minus 12 equals 0, which means n is equal to 12, and I get n plus 11 equals 0, which means n is equal to minus 11. Now I'm either saying that the 12th term has 397 blocks, or the minus 11th term has 397 blocks. Clearly that one doesn't make sense, so my answer is it's the 12th term. Okay, this is similar to one that we did previously. Again, when you get a question like this, you need to realize that it's a quadratic equation. What you need to do here is, instead of a 3 to the power of x, you need to sub in a y. And once you've identified that, that's your substitution, life is very simple for the last two terms. This is minus 28y plus 3 equals 0. My problem lies in the first term. My first term is 3 to the power of 2x plus 2, and I need to find some way of simplifying that down. An easier way of writing that is 3 to the power of x plus 2. Again, we use the same rule of powers as we used earlier, and which means that I can rewrite this as 3 to the power of x multiplied by 3 to the power of x multiplied by 3 to the power of 2. Now, based on my substitution, instead of a 3 to the power of x, I can put in a y. In other words, this works out as y multiplied by y, and 3 squared is 9. Which means that this whole term, simplified fully, is 9y squared. Now what you need to do is factorize this and find the value of y, so you can go back and find the value of x. So if you were to factorize this, you're going to get 9y minus 1 and y minus 3 equals 0. Obviously, to solve this fully, I need to let each factor equal to 0. 9y minus 1 equals 0, which means that 9y equals 1, which means y is 1 over 9. On the other hand, if you have y minus 3 equals 0, you bring a 3 to the other side, and you get y is equal to 3. Now, remember, a lot of people end up stopping there, and they only get 7 out of 10 for these questions. We invented y at the start of the question, so y is irrelevant. The reason we invented y was so that we could go back and find the value of x. So I need to go back on my substitution now. If y is equal to 3, that also means that 3 to the power of x is equal to 3. Now you can view this 3 as 3 to the power of 1. So clearly, based on this, you could just say that x is equal to 1. So your first answer for x is equal to 1. The next one here now is the 1/9. I might finish it up here. One of your rules of powers is that 1 over a to the power of p is equal to a to the power of minus p. Now, the first thing I would do, instead of the y, I would sub in 3 to the power of x equals 1 over 9. Clearly, if this is 3 to the power of something, I want this to be 3 to the power of something. So I could rewrite that as 3 to the power of x is equal to 1 over 3 squared, because 3 squared is the same as 9. Now if you look at this line and you look at the rule of powers I wrote down up here, 1 over a to the power of p is equal to a to the power minus p. Based on that, 1 over 3 to the power of 2 is equal to 3 to the power minus 2. So my left hand side is 3 to the power of x, my right hand side is 3 to the power minus 2. Clearly that means that x is equal to minus 2, and that's my second value. So there are your two values for x in this one. Okay, now the second financial maths question here was question 4. And in the first part of this question, we're asked to convert an annual interest rate of 3.5% to a monthly interest rate. Again, think of it this the exact same way as the last time. I would think of, right, well, this is my annual interest rate. The annual interest rate to the power of 1 is equal to my monthly interest rate to the power of 12. Because clearly you would apply the monthly interest rate 12 times in a year, the annual interest rate once in a year. Be very wary of percentages. We never use these formula when we're dealing with percentages. So in order to convert this percentage into a decimal, I need to divide by 100, which means that I is 0.035. So that's my annual interest rate, and I need to find the corresponding monthly interest rate. If I'm using all the annual interest rates on the left-hand side, that means I could say that the annual interest rate is 1 plus this, which is 1.035 to the power of 1. The annual interest rate to the power of 1 will be equal to the monthly interest rate to the power of 12. Now clearly the monthly interest rate is what the question was, so from here on out this is just algebra. I'm just trying to isolate the I. In order to get rid of the 1 to the power of 12, I need to get each side to the power of 1/12. The left hand side to the power of 1/12, I just write it like that. The right hand side to the power of 1/12 just becomes 1 plus I to the power of 1. Clearly that makes life a lot easier when I've gotten rid of the power here. To get I on its own, I just subtract 1 from both sides, and I get 1.035 to the power of 1/12 minus 1. Now if you plug all of that into your calculator, you get what they were asking you to prove, so you end up with I is equal to 0.00287. Now they asked you to write this as a percentage, or to prove it's 0.287%, so in order to do that, I just multiply both sides by 100, and I end up with I is equal to 0.287%. The monthly interest rate for this question is going to be that. Okay, so in A part 2 of this question, we're told that Dan and Kate are saving up for a deposit on their house. And the deposit on their house is 10% of the cost of the house. 10% of 250,000 is 25,000. We're told we've worked out the interest rate is 0.00287, and they're going to save €500 per month. So in this case, you should write out your geometric series. First of all, if they're saving money, that means you know that you're dealing with no fractions. You should be subbing into this formula. If they're saving money, you know you're subbing into this formula. So what you always look out for is, are they saving at the beginning of the month or the end of the month? In this question, they're telling me that they're going to save at the beginning of the month. So let's say that it's going to take them 40 months to save this much money. That means that the first investment will be in the account for 40 months exactly, because it was in there from the very first day. So in this case, I'm saying that it's going to take them n months to save 25,000, which means that the first investment will be in the account for n months. So the first investment was €500, and the amount of interest they're going to earn, to represent that, it's 1.00287. If the first investment is in the account for n months, or in other words, if it was 40 months, that means the first investment would be in the account for all 40 months. In other words, whatever this is, the first value is just to the power of n. Their first investment will earn interest n times. The second investment, we could represent it as 500 times, the interest rate stays the same, but this one is in the account for 1 month less. If it's in the account for 1 less month, that means it earns interest 1 less times. In other words, it's the interest to the power of n minus 1. Now there's loads of terms in the middle here. We actually don't know how many, but we know for a fact the last investment is going to go into the account at the start of the last month, which means that it's in the account for 1 month in total. So the last investment can be represented as 500 times the interest rate to the power of 1, because the last investment goes into the account at the start of the last month. In other words, it earns interest once. Once you've got your geometric series, we can now work on working out how many terms there actually is in this series. How many of these do I need to add together so that they add to 25,000? And in order to do that, you need to sub into your formula Sn is equal to A times 1 minus or to the power of n over 1 minus or. Now, 3 plus 4 plus 5 is the same as 5 plus 4 plus 3. So rather than taking this as my first term, I'm going to flip it and say that that's my first term. It's much easier to use that because at least there's no unknowns there. So I'm going to say that my first term is equal to 500 times 1.00287. And the common ratio would be any term divided by the previous term. In this case, it's going to work out as 0.00287. N is what I'm looking for. The number of times I'm going to have to save 500 euro is unknown, so we can just leave that as n. And Sn, I know the total value there. My Sn is going to work out as 25,000. This will tell me how many months it takes for Dan and Kate to save up 25,000 euro. So I want you to sub in there and see if you can work out the value of your n. Now, obviously, your substitution here is as difficult as you can get because your unknown is in the power. What I've done is I've subbed in Sn is equal to A times 1 minus or to the power of n over 1 minus or. In order to get rid of my fraction there, I multiply both sides by the denominator, so I get 25,000 times 1 minus or. The next thing I wanted to do was isolate this part of the right-hand side, so I divided both sides by 500 times 1.00287. And that's what I have on this line. What I wanted to do next was I plugged all that into my calculator and I got minus 0.143. I got this. I think it's really important to go to 6 or 7 decimal places in this topic, so overkill is underrated in this topic. Make sure you go to as many decimal places as you can. Then what I did was I brought this term to the right hand side and it became positive. I brought this term to the left hand side and it became positive. It's important because if my unknown is in the power, if I'm going to introduce logs, I need that to be positive. So I'm going to continue this one on from the top now because I'm going to run out of space. Okay, so the problem I have here is my unknown is in the power. If my unknown is in the power, the only way to simplify it is, the only way to find the value of n is to introduce logs. So I'm introducing the natural log on the left, the natural log on the right. And the reason I did that is because then I can bring my power in front. Now I just have n ln of this number. So in order to isolate my n, I divide both sides by the coefficient of n, and I end up with ln of this divided by ln of that. Plug it into your calculator, you get 46.67, and obviously we can round that up to 47 months. It's going to take Dan and Kate 47 months to save 25,000 euro if they're investing 500 euro a month. Okay, in the next part of this question, we're told that Dan and Kate find the perfect house after 3 years. So in the previous part we worked out it was going to take 47 months for them to save for a deposit. Obviously in 3 years there's only 36 months. So that means they've only saved a certain proportion of the 25,000 that they needed. And we need to work out how much money have they saved within the first 3 years. And when we work that out, we can work out how much money they need to borrow so that they'll have the deposit for the house. So the first part of this question is relatively straightforward. First of all, it's the exact same savings, it's the exact same geometric series as we used in the previous question. They're still saving 500 euro and the interest rate is the same, so the first term stays the same, the common ratio stays the same. The only thing that is different is now n is equal to 36. If I sub in these values, this is going to tell me how much money Dan and Kate have saved in the first 36 months. So you'll notice here I've subbed into my formula for Sn of a geometric series, and it works out as 18,988.51. That's the amount of money they had saved in the first 3 years. Obviously they were planning on saving 25,000 in 47 months. So I want to work out how much money have they got left, how short are they? So 25 grand minus the amount of money they've saved means that they still need 6,011 euro and 49 cents. And this is where they've told us that they've taken out a loan in order to pay this. So now we know the value of the loan and we can work out what the monthly repayment was. Okay, so in the previous slide there, we worked out that Dan and Kate must have borrowed 6,011 and 49 cents. That's how much money they've borrowed, and they plan on paying it back over the course of 5 years. The monthly interest rate we're given as a percentage. So in order to convert that, in order to get that so I can use it in my formula, I need to divide it by 100. So rather than 0.425%, you're going to write it as 0.00425. Now, Dan and Kate are paying back a loan. If they're paying back a loan, that means that we're working off of this now. Basically, it means you're using your fractions. It's a fraction because they're paying a loan back. It's the annual repayment divided by your interest. So I can work out my geometric series here. I know that all of the repayments added together must add up to $6,011.49. Now, they don't have to specify whether the repayments are made at the start or the end of a loan, because logically, nobody pays back a loan at the start of the month. Because imagine if I got a loan from you today, I'm not going to give you your first installment or your first repayment today. I'm going to give you your first repayment in a month. So you can work off the assumption, if they don't specify, that a loan is always given back at the end of the month. In other words, what that means is so I'm representing A as the amount they're paying back. And so the first repayment is made a month after the loan was issued. So in other words, that the interest rate, a monthly interest rate, has been applied once. The second repayment was made 2 months at the beginning of at the end of the second month. In other words, 2 months after the loan was issued. In other words, interest has been charged twice. Now clearly there's 60 months and 5 years, so there must be 60 terms altogether. So the last repayment was made 60 months after the loan was issued. In other words, interest has been charged 60 times since the loan was issued before that repayment was made. Once I have my geometric series, I can work out my first term, my common ratio, I know my Sn, and I know the number of terms. Once I know all of these, I can just sub into the sum of a geometric series, and I should be able to work out my A. So if you didn't get a chance to do this, I want you to try that one now, and I'll do it on the next slide. Okay, so you can see here I've subbed in Sn equals A times 1 minus or to the power of n over 1 minus or. The first thing I would do here is multiply both sides by the denominator. In other words, bring up the 1 minus that bracket, and that comes on the top. Now I've done two things in one line here. What I also did was, so I'm multiplying both sides by that, so this bracket goes on top, and I'm dividing both sides by this. So I also divided both sides by this, in which case that goes on the bottom. And all I'm left with on the right is A over 1.00425. And then in order to get A on its own, I multiply both sides by the denominator, so it's that messy fraction multiplied by 1.00425, and that gives me A. So you plug all of that into your calculator in one go, and you get A is €113.72. And that's my final answer in this question. So in other words, if Dan and Kate decide to stop saving for the deposit after 3 years, they've saved about €18,988, which means they still need to save this much money. Instead, they take out a loan, and they're charged a different rate of interest on the loan. If they pay back €113.72 every month for 5 years, they'll have paid back that loan, and they'll have come up with their deposit. So that's your final answer for this one. The final question I'm going to do in this video is, there's two parts to it, and this is the first bit. It's just algebra. You're given the difference to squares. Well, looks like a random enough y cubed, y squared, a y, a quadratic, and just something that you can factorize out what's common. X squared minus 4 is just the difference to squares. All you can do at the bottom of this is factorize out your y. For the moment, all you can do at the top of this is factorize out your y, and the bottom of that is a quadratic equation. All you can really do on the second line here is realize that this is a y squared, a y, and a number, so that's a quadratic as well, and you can factorize it. When you get to this stage, because that's a multiply, anything that's on the top and on the bottom you can cancel out. So 3y plus 1 cancels with 3y plus 1, y cancels with y, x minus 2 cancels with x minus 2. You have to make sure you write your final line. So a lot of people lose marks because they don't write what they're left with. So what I'm left with on the top is x plus 2 times y minus 1. What I'm left with on the bottom is x plus 3. So my final answer there is just that. Okay, the second part of that question now, this is a very common question in the leave insert, is you got 3x minus 2 over x plus 4 is less than 2. Now, when you get something like this, if you have a fraction, an algebraic fraction and an inequality, you multiply both sides by the denominator squared. The denominator in this case being x plus 4. If you multiply you need to multiply the left by x plus 4 to be squared and the right by x plus 4 to be squared. If you multiply the left by x plus 4 to be squared, the x plus 4 on the bottom will cancel with one of these, and you're left with x plus 4 times 3x minus 2. Now, if you multiply that out, I skipped a line, but you can multiply it out as double brackets. You'll get 3x squared plus 10x minus 8. If you multiply out the right-hand side, you'll get 2x squared plus 16x plus 32. Clearly, there's an x squared, an x, and a number, so you bring everything to one side, and you get x squared minus 6x minus 40 is less than 0. Now, in order to solve this question, I need to solve for x. So I need to change my inequality to an equals. So now I'm going to say just let the quadratic equal to 0. If it was equal to 0, my factors would be x minus 10 and x plus 4. So my roots would be x equals 10 and x equals minus 4. But that wasn't the question. The question was, when is this quadratic less than 0? You go back to the last point you had an inequality, and that'll allow you to figure out what your inequalities should be. Now, my advice is always sketch a graph for these ones. So I've sketched a graph here. I know the roots of this quadratic are 10 and minus 4. In other words, it crosses the x-axis at 10, it crosses the x-axis at minus 4. Which means, and the question was, when is the quadratic less than 0? If it's less than 0, that means the y value is negative. In other words, it's below the x-axis. So I've shaded that region in here. Clearly x is below the x-axis between minus 4 and 10. So your answer is x needs to be greater than minus 4, but it needs to be less than 10. And that's your final answer in that case.